We are recording now. Okay, welcome all to this core interim meeting, last of the series before 1.9. It's Marco and Jaime chairing. Not well applies. Please get aware and confident with them if you are not already. And that said, we can switch to the presentation from Christian of this document then.
Yep. So I'd like to go with you through what I think are the next steps for making OSCORE cacheable and for accessing, basically to get deterministic requests here. Next slide, please. So just to get everyone on the boat again, this is coming from the work about multicast notifications. There we have the case that the server can tell the client that there is already a request that is being actively responded to, and the server can tell that client that request, and all is fine for that matter. So the client still needs to verify that request, but that's not too big of an issue, and there is no need for determinism there. But that only flies well when we are in a situation where there are many responses to a single request. If we want to just use a cache more efficiently, then sending the request, getting the proper request back, and then going with that request to the key for all but corner cases, of which multicast notifications is one, doesn't save a lot. Next slide, please. So for today, I'd like to focus this on the deterministic requests part of cacheable OSCORE, which really is the thing where I'm trying to get at there. So there's a lot of things like token requests in there that basically abstract away from the multicast notifications, but deterministic request is the core of the thing, and that's what I'd like to talk about and not get lost in details about all the steps for getting there. Next.
Just note, probably with token request, you meant ticket requests.
Oh, yes, ticket requests, and it's probably the same all over the slides. If I start making such a mistake, then I'm very consistent in doing it. Thanks, yes, ticket requests.
Okay.
Next slide, please.
Sure.
So this is what I imagine this should look like in the end. The client sends a request that is a regular OSCORE request. That's in a fetch rather than a post, because it might be observable and because this is generally what enables all the caching. OSCORE doesn't forbid that. It uses a pre-set up member key ID from within a group. I'll get to that group later. Then it adds one thing that is not there in OSCORE yet, that is a key ID detail, which really works. Think of it for all intents and purposes as the KID context, just that we can use KID context and KID detail at the same point in time. And then the rest of it is the remainder of a request message. The KID detail, in order to get these deterministic requests that we want, where many clients can produce a request, and that is byte by byte identical, to the point where it doesn't even count as nonce reuse because it is just the same message. And to avoid using the same key for different requests, we have to find a way to use a different nonce. So what I originally planned to, and what just doesn't work out because of the size constraints, is to use that hash in here that I'll talk about right away as a nonce. We can't use it as a nonce because the nonce is quite limited in this application. So this goes really into the key derivation. This would be so what the client would do is it constructs the request as kind of the inner request, hashes that along with the AAD, and puts that hash into the KID detail. That goes into the key derivation process. A key gets derived. It encrypts the request, sends it to the server, and the server uses the same key to respond to that request. So yeah, and next slide, please. So what do we need for this? We need.
Yeah. Sorry, Christian. I take it you were ready with the explanation. We should understand why this is cacheable now.
Yes. If it's not
please explain carefully why this is cacheable now.
Okay. This is cacheable now. So on the technical side, this is cacheable because it's using fetch, and as long as the server in the response chooses not to send the max age to a ridiculously small number, then the proxy will, by the option properties that are in here, cache that response. So that's the technical side why this is cacheable. On the practical side, this is cacheable because many clients that send the same request by what they mean will also arrive at the same request in terms of bytes that are in there, because what they mean is encoded in the inner option, that is the get, the temp, the URI, and any other inner options. And because everything else is deterministic on the group that this is set up with, which we'll largely gloss over here, but there needs to be a group that's set up. As long as those are the same and the group is the same, everything else in the request will also be the same.
Okay, so you're saying that you make sure with this construction that the cache key will be the same for the different requests.
Yes.
And that is assuming then that you actually have a group here and you're sharing a key in the group.
Yes. So the way.
How is that? Okay. So you can't cache unless you are in the group.
Yes, you have to be in the group, and the expectation, similar to the multicast notifications, is that the server, that a server where clients would do this advertises a group and allows for the clients to join that group.
So in this setting, one client would be able to fake responses would be able to fake server responses, or do we have any?
So the thing that prevents the server from any other client from faking server responses is that usually with group OSCore, and this is all group OSCore, and I'll get to why it's not here in this line, that at the end there is a signature. So while any client can send requests and they are not even distinguished. So if it says KID equals client here, that's literally client in the sense that there's one key ID that every client is using, but the server is using a different sender ID to respond, and the server will use the regular signatures that are there for group OSCore.
Yeah. Okay.
Carsten has a comment in the chat. I don't know if
yeah, just Jeroen saying you can't cache unless you are in the group. The proxy does the caching, and the proxy is not necessarily in the group. So I think what you meant to say is you cannot be part of a successful caching transaction as a client or a server unless you're in the group.
You can't hit the cache without being in the group and still make sense of it.
Right.
Great. Yeah, thanks for the clarification. So could I somehow after, okay, so I can't join. I just wonder, if I'm not part of the group, could I join, could I realize that I should join the group? Or maybe this goes beyond the discussion here, but.
So if you don't already know that you should join the group, then you will try to get to send the request in a regular way. Yeah. And we might apply the concepts of multicast OSCore to redirect that client towards joining the group and doing it in the deterministic way. But in all cases, but those special cases, we can just respond as well. So the client has to have some pre-configured or discovered knowledge of that it should use cacheable OSCore for this.
Right. And or it could get the answer and an attachment saying, by the way, next time, please join the group.
Yes, that would be a good thing.
Okay, thanks for explaining. Please go ahead.
So maybe just to go into one example that I have in mind here. Yeah. This could be well usable for firmware updates when the client when a lot of clients access the same resource, and then they can just all send their requests, and they know that others will do this too, and they will know a bit about the firmware server and will join that group first, and then they all hit the same cache at the border router or even within the network.
So just a follow-up question: the signature is not included in the cache key then?
The signature, if there were any signature, it would be included in the cache key, and that's the point for the next slide.
Okay, because that would be different signatures for different clients, right?
Yeah. So maybe let's go to the next slide right away, because that's that important topic.
Fair enough.
So no signature. Why don't we have no? What it says in the dash, I think it's still the dash 00 that I've uploaded last, is that we would use that basically every client would get access to the private key material that is associated with that client, and then deterministically arrive at the signature. That construction was put in there primarily because the syntax of group boss core does not allow for no signature to be here, and also because there were previous discussions around group boss core that where the participants insisted very heavily on source authentication. Thing is, by now I don't think this is a good idea, because while it's technically avoiding all those pitfalls, it's practically just a workaround for the core questions that there is. That is, why do we not need source authentication here? And if we can argue that we don't need source authentication, which we'll have to do if we want to sell to anyone who objected not having that, that we are now sharing private keys, we can just as well explain to them that for these particular cases, no source authentication is necessary, because in the end, if there were source authentication, this would all not be cacheable anymore. And on the other hand, everything that we say around where this can be used will very precisely state that this can only ever be used if the requests have no side effects on the server.
That makes sense. Okay, so you actually don't sign the request in this case.
Yes. So what I propose and what I think should be easily doable with actual implementations is that this particular participant of the group, that is the client, picks a different signing algorithm than is generally used with that group, and that signing algorithm is the null algorithm, in which nothing is actually signed and the signature is 0 bytes long. And I understand this algorithm exists, but it's not talked much about because it's not actually doing anything, but it might still have a number somewhere.
So effectively, the request is still macked by the group key, right?
Yes. So
that needs to be part of the explanation.
Yes, but yeah, so it's still macked. And at any rate, I mean, the thing is, even if it were not macked, I don't think it would make much of a difference, because the server must only process the request if it's safe to do so. Sure, the MAC is an additional safety mechanism. That means that if someone finds a way to exploit something in the message processing, they can't even get there without being part of that group. But that's an additional security mechanism against implementation errors, and not a requirement for the confidentiality of anything in here, or for the side effects that could be.
So you're arguing with safe. You also need to think about work avoidance for DOS protection.
Yes, and for work avoidance, the Mac certainly does a thing.
Yes, much better than a signature.
Yes.
But what is the difference between one group, the second group member sending calculates the message using the group key, or that the second group member copies the first request? Aren't they identical? Isn't that purpose.
That's the point, that they will be identical. I don't quite understand the question, I think.
Yeah, they are identical. So it's not. It's basically no. Yeah. So the value of the MAC is not on the proxy. The proxy will receive the same message and it will respond to the same. Yeah.
Yeah. So back one slide, please. So yeah, I think we've talked about the group members. Other prerequisites here are that we have to have a deterministic AEID algorithm. And I've mentioned that the last time I presented about this, we can probably have a flag in the OSCORE registry that says, is this algorithm suitable for this thing or not? And chances are that no algorithms will work for OSCORE anyway, where this is not the case, but I'm not sure, and I wouldn't require that. And yeah, the other thing is no two messages must ever use the same key with the same nonce, because many of our algorithms will behave very badly if we allow that. But given that everything that goes into the later encryption process is also part of the key derivation, it will not provide. It should not ever result in the same key being used to protect different things with the same nonce, unless there are collisions in the key construction. Yeah, and the last point here is, sure, this all depends on the clients all arriving at the same inner request, but if they don't, yeah, so what then? There will be a few variations, can't be avoided, or if it can, that's out of scope for here.
Okay, I think you have reached the point where you actually deserve a good review. I can't provide that right now, but I think this is really worth something to think about. There are various ways of doing the things you talk about here, exactly how to make sure that the key is different and setting of the nonce and so on.
Yeah.
So we should discuss the options there. Sorry, I haven't provided any input since last meeting.
No problem.
Really prioritize this after the next meeting.
Mm-hmm. So one thing where I hope to get a bit of input from you is also in comparing this with the previous work on OSCON, which I don't really know for which reasons that was removed from OSCOR. But I think that in the end, this is doing something very similar.
Yes, so it was removed because that was mainly related to the pub sub work, and we didn't need that. So the pub sub didn't progress and still is not moving very fast. So that was the reason why it was taken out. And I think that there might actually be other reasons to bring back something like OSCON. Some people think of using ad hoc, but not OSCOR. And maybe we would like to have that, I mean, ad hoc to set up something which you transport cozy objects between, and then you'd like to have similar features as OSCOR with replay protection and the nonce generations and so on. So that might be another reason why we should revive it.
I mean, this will not help with replay protection. So the server-side handling of this pretty much relies on replay protection being switched off, which can only happen if the request is safe, which is a prerequisite anyway. So it works here, but if anything else wants OSCOR's replay protection, it probably won't go through this channel.
Okay, that's a good point. So let's see what is the right what you need except the I mean, OSCON was essentially doing the things we did in OSCOR, but not taking into account that this was necessarily a RESTful operation. This was just a payload.
Mm-hmm.
That was maybe the difference, and whether replay protection is needed or not, we could. I need to revisit that. I can't.
Mm-hmm.
So I guess it's 2 slides forward now.
Yes, although it's...
Michael Richardson just joined, by the way.
Hi, Michael.
Hello.
Michael
yeah.
Richardson, co-chair. Who's that guy?
So there's one point I've added to the slides really as an afterthought, but this comes also from the comparison with information-centric networks. Once a client is rather confident that this request is probably already in someone's cache, at least in the server's cache, which I mean the server could have an internal cache, then it might be an option to really practically only transport that hash at all, elide all the other options and the payload. And for this would additionally require that the proxies in between recognize this particular flag in the OSCORE option and treat this as the sole cache key as opposed to taking the payload into account. If this fails, the server will respond bad request and the client would have to go around and resubmit the full thing. But as long as it doesn't fail, this just allows for a lot shorter requests, which may make a difference when there's a lot of them coming in and hitting the same cache. But that's, I briefly thought that this might this might be relevant as a way of avoiding the signature situation, but really it doesn't help here.
Sorry, Christian, I didn't catch this. OSCORE option with this flag set could be used as standalone. So what is this flag?
What did I call it? KID detail.
Is that a new?
That is the new OSCORE. That is the new.
There's a new flag. Yeah, there's a flag.
The new thing.
Okay.
The new thing I'm introducing.
Right. Okay. So with that set.
And technically, we might consider using another flag here to ensure that the client, the proxy, really only does this when it's a good idea. I don't know yet, but
okay. And why would that be standalone?
So usually the cache key is composed of all the options that are cache key plus the request payload.
Yes.
And this option, with this, the OSCORE option would get a special handling by a proxy in the sense that the proxy may use this option alone as the cache key as opposed to using all those other things, which means that a request that only consists of the hash of the request as opposed to the full request, including the hash, will hit the same cache key and will thus inhabit the same place in the cache.
Okay, thanks.
But really, the important questions are on the slide one back from here, if there's any more comments here.
I have a question on the fetch semantics. Like, does it need some sort of specific semantics like SNML fetch or SNML iPatch did, or is kind of like assumes that the semantics are understood, or?
So this fetch is already part of OSCORE for regular request for kind of as it is now. It's just only used for observation because you can't observe a post, but you can observe a fetch. And funnily, there's nothing in RFC 86613 that forbids the client to use fetch for requests that don't happen to be observed. So really, it's just as good as a post. And there's no real semantics to much of it because the semantics layer is only there when you when the OSCORE layer is removed, and by then it has the proper get or fetch code of the inner message, where then any SNML fetch semantics could apply. Okay,
so it will be the same existing SNML semantics that would apply afterwards.
Yes, but that would be about the inner code. So if you go back 2 slides.
Okay, so okay, sorry. Go ahead.
One more.
Right.
Yeah. So there's the inner code that's in the second line from the bottom. That's the get, and this is where all the regular. So this is the actual request in a sense. This is the request that gets processed by whichever handler is there on the server. The outer code is just there to satisfy the semantics of a co-op request without giving away anything about the content.
Okay, so it could have been a post or whatever else as well.
It can't have been a post because a post is not safe.
Yes, sorry. Okay. I think I got it this time. Thank you. Okay. So it doesn't really need any kind of semantics at that point.
We were here, and looks like the last one anyway.
Yeah.
Thank you, Christian. Any more comments or questions? Okay. Well, I stop sharing this. And we can then switch to the other topic, stateless. But Michael has a comment, in fact, in the chat.
I'm just really, since I missed half the conversation, I'm just asking if I understood correctly. If for idempotent actions, the request is blinded, that is encrypted or something, so that the cache can't see the request response, but can still cache it. That's what I understood. Yes. The whole point.
Yes. Yes.
Cool. That's really neat. Shades of Johnny Mnemonic, but anyway. Stateless. So the issue that remained was the question of how do we generate, or what advice do we give for the size of the replay window? And Karsten indicated that my text was inadequate in a way that he didn't yet understand or hadn't yet determined.
I think I fixed it in the most recent push to the pull request 15.
Oh, did you?
I think.
Okay.
I want to hear from people who are smarter than I whether I'm right.
Marco, can you show the pull request?
Yes, was about to ask if Michael wanted to, but I can.
I'm not there yet. I'm typing the right.
I can do that. No worries.
Okay, fixes for 07.
Right, here we are.
Well, as you can see, there are a few typos, but further down.
Here.
Why are you not seeing the whole thing? That's weird.
I can expand here, but it should be about unchanged things, though. Let's.
Can you maybe just go on the commit?
I think it's just, yeah, go to files changed. That's the problem. Oh, okay.
Which comment, Karsten?
Yeah, go on files changed.
Okay.
Yeah, it's line 923, I think, is the relevant part.
Here we are.
Oh. Okay, so just go on the second commit. I have no idea why GitHub is doing this. I've been in this position before. Yeah.
This one.
Looks right. It looks like right to me, and my files changed when my.
Interesting. Here.
Oh, but I only see, yeah, one. There we go. Yeah, that's the right part. I think that's the right part.
Yeah. And I updated that once more. It no longer says 0.1 requests per second, but 1 request per 10 seconds.
Okay.
Which is
so
the same
93,
thing.
Given a max transmit wait of 93 seconds, where did that number come from? 93. Is that a default?
Yes, if you go into 7252, it's not a default. It's when you compute what max transmit wait needs to be with the default parameters in 7252, you arrive at 93. That's why I'm using that.
I think we should motivate the 93 somehow.
Well, it's motivated in 7252, so maybe we should just reference that.
That's
section.
What I'm saying. That's what I'm trying to say. Given them.
Yeah.
From RFC 7572 Did I get that right?
7252.
7252. I have twice cited the wrong RFCs by typos of dyslexia, and had ADs ask, "Why are you citing that?" And I went, "I don't know."
So it's section 482. I can put this into the pull request.
It's in the minutes too. I'm taking the notes as well.
Okay. If you hit reload, you'll get. I think maybe you have to go to files change to get the suggestions. Okay, so one request per 10 seconds. Yes, any request that is not answered within 93 seconds will be considered a failed. Thus, at most 10, that is ceiling 9.3 requests can be outstanding at time. Okay. Okay, so you're basically coming up with the same statement that 32 is plenty, and in fact, it's even better than plenty, because the nice part about it being larger, at least 8 bigger than 20, is that it means you can shift it by bytes rather than bits as you increment your low water mark.
Just an editorial comment. The value of max transmit weight alone should be sufficient to understand that any request not answered within 3 seconds will be considered to have failed, right?
Yeah.
Yes. So we may rephrase as, for instance, given a co-op max transmit weight of 93 seconds, any request that, blah, blah, blah. Thus, if we consider a request rate of 0.1, then at most 10 requests can be. See what I mean?
Why
Yes.
don't you let me share, and we'll type what you just said.
I'm typing this in right now.
Okay.
I can write what I mean in
well, you just
here in the end. Right. So this should be already correct, right? And well, the rest of it.
right. Well, I'd suggested something after 93S. So let me just put those two things together.
Yeah, I've just pasted the remaining text.
Okay, if you're happy with that, then I will spin the document in as soon as I'm able to, and let the AD know.
Yes. I checked the whole document again, and this looks all very good, actually. And I think there are still 2 open issues on GitHub, but one is won't fix, and the other one I think was addressed in the document, so probably they just have to be closed.
Yeah.
Right.
Yeah. Okay, so that's great. Then I guess we're done. I don't have anything else more.
Great. So I think you can resubmit as the resubmission system reopens.
Okay.
So can you also take care of replying to the reviewers?
Yes, I will do that.
That's great. Thank you, Michael, very much. Another point I had in the back of my head is for Karsten, how are we with the Shepherd write-up of the core conf documents?
I have a little distraction at the moment because RFC 8949 is in auth 48. So yeah, it's another delay, but it's going forward slowly.
Okay. I think Michael was also eager to see, especially speed proceeding. Yeah. Can it happen around 109 or right after it?
Preferably before.
That would be very great. Thanks, Karsten. Okay, we are at the end of the originally planned agenda for today. Anything else you wanted to discuss or raised before 109? No? Okay, so this was the last interim for this series, and we actually plan to have a new series starting around mid-January, ideally, until 110. Otherwise, we have 2 sessions for core planned for 109 on Tuesday and Friday. And we have a draft agenda. Please provide feedback if you want to give more input or propose changes. Okay, if there's no other comment, thank you all for today. See you next week at the hackathon and at 109.
Thank you.
Thank you very
much. Thank you.
Jaime?
Hello, Christian. Yeah.
Just if you still have the allocated remaining time of the meeting, we could go through the Shepherd stuff right away if you want.
Is it? I was hoping to do a bit later today because I haven't touched it for a long time.
No problem.
If that's okay. And also I have the daughter. I haven't seen her since 8 a.m. So I want to chat or at least make noises. Thanks.
Okay.
Hey guys.
See you
Ciao,
tomorrow.
ciao.
Soon. Bye-bye.
Bye.